is sharing a stunning view of Neptune and its rings taken by James Webb telescope. It's the telescope's first image.
The telescope is providing a crisp new view of the planet's rings, and it's the first time NASA has seen them in infrared.
When NASA released Webb's latest infrared images of Neptune, the agency expected routine data, not evidence that would overturn 3 decades of assumptions. Yet, the images revealed the clearest view of Neptune's rings since Voyager 2 in 1989. It's also the first time NASA has seen the rings in infrared, and the telescope picked up several bright, narrow rings as well as fainter dust bands. Pretty incredible. These findings forced researchers to reconsider what they thought they understood about the ice giant. The story that follows is nothing like the quiet update astronomers expected. Webb's infrared clarity exposed structures, energies, and behaviors that had been hiding in plain sight, waiting for an instrument capable of revealing them. The truth behind Neptune's sudden transformation will surprise you. A telescope built for questions. NASA never expected Neptune to shock them. Webb wasn't even built for planets. It was designed to look at the first stars in the universe, not the cold, distant worlds in our own backyard. Its job was to study galaxies older than Earth itself. And yet, the moment Webb's infrared sensors turned toward Neptune, something happened that no one in the control room was prepared for. Infrared light did what visible light never could. It sliced straight through Neptune's methane haze. Suddenly, the atmosphere darkened, the glare disappeared, and the planet's hidden structures, rings, storms, temperature bands, lit up like someone had turned on a cosmic X-ray machine. The first raw frames arrived, and for a moment, several scientists believed the system was malfunctioning. Neptune's rings weren't supposed to look this sharp. Its atmosphere wasn't supposed to show this many layers. Features that had been invisible for 30 years were suddenly unmistakable. Webb had revealed Neptune with more clarity than any telescope since Voyager 2. Not after months of processing, not after calibration fixes, instantly. And that was only the first surprise, because when NASA zoomed in, they realized this wasn't just a clearer picture. It was evidence that parts of Neptune's system had been misunderstood for decades. The ice giant that resisted clarity. Neptune has always been the planet that refused to cooperate. Since its discovery in 1846, every attempt to study it pushed our technology to the edge. At 30 times farther from the sun than Earth, even daylight, there is barely brighter than twilight here. Getting a clear look was never easy. Astronomers spent decades stretching their instruments to squeeze out whatever detail they could. Every long exposure, every filter, every clever technique fought against the same problem. Neptune's methane-rich atmosphere scatters light so strongly that deeper layers stay hidden. Hubble sharpened the view a bit, but its images still left questions. Bright clouds showed up clearly, but storms blurred. Darker regions swallowed important detail, and the rings barely registered at all. Even the best ground-based telescopes struggled. Earth's atmosphere distorted the view, and Neptune's faint rings and tiny moons slipped in and out of visibility, depending on weather, timing, and luck. For more than 30 years, Voyager 2's brief flyby in 1989 remained the most complete data set we had. A single snapshot, locked in time, impossible to revisit. By the early 2000s, as astronomers collected better data from distant exoplanets, Neptune remained strangely out of reach. The closest ice giant in our own solar system was still the one we understood the least. Huge questions hung over it. Why its winds are the fastest in the solar system. Why its clouds appear and vanish without warning. Why its magnetic field is tilted and off-center, and whether its rings were hiding more structure than Voyager ever saw. Neptune was mysterious because our tools weren't sharp enough to reveal them. That's why Webb's infrared images became such a shock. They didn't just give scientists a better picture. They finally broke through the barrier that had kept Neptune partially hidden for generations. For the first time since 1989, the planet stopped resisting clarity. But first impressions. When Webb finally turned its gaze toward Neptune, NASA expected an incremental improvement. Cleaner clouds, slightly sharper storms, maybe a clearer outline of the dark spots that drift across the planet's atmosphere. No one expected the shock that followed. The first raw frames arrived on NASA's servers, looking nothing like past infrared observations. The contrast was so extreme, so unnatural, that several researchers assumed there was a calibration error. Neptune's rings, nearly invisible for more than 30 years, weren't just visible. They were glowing, not faintly, not subtly, but sharply, clean arcs of brightness, surrounding a planet that until this moment had been one of the solar system's most stubborn mysteries. What stunned the team also was how quickly they overturned decades of assumptions. Major discoveries in planetary science usually unfold over months, sometimes years. But within the first hour of analysis, scientists were already revising models. By the third hour, some long-standing arguments from the Voyager era were effectively settled. One researcher later described the moment as the first time the data outran our models instead of the models outrunning our data. For a planet that had been observed for 176 years, but understood only in fragments, Webb's clarity was disorienting. Neptune's methane-rich atmosphere, normally a blinding sheet of reflected sunlight in visible light, turned nearly black in infrared. That sudden darkness acted like a cosmic dimmer switch, revealing patterns and features that had been completely hidden for generations. Bright methane ice clouds floated above the darkened background like illuminated storm tops. Their altitude, shape, and thickness could now be measured, not guessed. The equatorial region, long predicted to behave differently, lit up in infrared, confirming years of suspicion that Neptune's deepest winds heat the atmosphere from below. But the biggest shock came from the rings. Voyager 2 had imaged Neptune's rings in 1989, but only faintly. Each arc was a whisper in the noise. Since then, telescopes on Earth had tried with adaptive optics, rare weather conditions, and heroic image processing, but the results were inconsistent at best. Even Hubble, with all its power, failed to produce consistent ring imagery. Webb succeeded instantly. The two main rings, Adams and Leverrier, appeared not as fuzzy suggestions, but as fully defined structures, complete with variations in thickness, brightness, and suspected dust concentrations. The faint inner dust bands, those ghost-like streaks Voyager barely caught, showed up with an almost unnatural clarity. For the first time since the 1980s, scientists could study Neptune's rings without uncertainty. At the same time, the surrounding moons became visible in a way they had never been before. Small satellites like Naiad and Thiassa, usually swallowed by Neptune's glare, appeared as clean points of light. It was the clearest structural picture of Neptune's entire moon and ring system in more than 3 decades. Even the scientists who had spent their careers preparing for Webb's capabilities were shocked. A telescope designed to study the first galaxies in the universe had just produced the clearest view of Neptune in modern history. And then came the moment no one expected. Triton, Neptune's largest moon, appeared brighter than Neptune itself. At first, the team believed the detector had saturated. It hadn't. Triton's nitrogenized surface reflected infrared light with such intensity that it overwhelmed the planet behind it. That single detail told scientists more about Triton's surface chemistry than years of previous research. Suddenly, The team realized they weren't just looking at a clearer photograph. They were witnessing a paradigm shift. Neptune wasn't just clearer or brighter. With Webb's infrared eyes on it, the planet finally showed the structure beneath its haze. Rings, clouds, and magnetic quirks that had been hiding in plain sight for decades. Within hours, NASA went from expecting routine solar system observations to facing a set of discoveries that would challenge models built over the last 30 years. This was no longer a quiet planetary update. This was the clearest view of Neptune since Voyager 2 and the beginning of a scientific recalibration no one saw coming. The rings reappear after 3 decades. If Webb's first images delivered the shock, the rings delivered the confirmation. Neptune had been hiding far more than anyone realized. For more than 30 years, Neptune's rings existed as scientific ghosts, real but barely visible. After Voyager 2 captured them in 1989, astronomers had hoped newer telescopes would reveal them again with that same clarity. But nothing came close. Not Hubble, not the world's largest ground-based telescopes. Not even adaptive optics during rare perfect weather. Every attempt produced the same frustrating result. Hints, smudges, suggestions, but never a true return. So when Webb's first infrared images landed at NASA and the team saw 2 sharp, luminous arcs cutting cleanly across the darkened planet, the room went silent. The rings were back, crystal clear. The effect was so unexpected that the first imaging specialist on shift reportedly whispered, "This can't be real. Check the filters." But it was real. The filters were correct. And Webb hadn't just revealed the main rings. It had exposed the entire system. The atom's rings stood out like a razor-thin arc of reflected infrared, every segment glowing with structure last seen only in Voyager data. The faint Levier ring reappeared with astonishing symmetry, and then came the real surprise, the dust bands. Voyager had detected them only as faint streaks, so faint that some scientists doubted they were structurally stable. But Webb's infrared clarity brought them into full view, showing delicate concentric threads of material that had remained invisible for 3 decades. This was the first time in modern history that Neptune's entire ring system was visible in one frame. Better still, Webb captured the slight asymmetries, tiny brightness variations, hinting at gravitational resonances caused by nearby moons. These patterns, barely detectable in the 1980s, now appeared with enough precision to refine models of how the rings are shaped. For the first time, scientists could revisit long-standing arguments about the arcs in the atom's ring, those mysterious segments that remain confined rather than forming a continuous band. Voyager's data hinted that small shepherd moons were stabilizing the arcs, but the evidence was incomplete. Webb tipped the scales. The brightness variations aligned perfectly with predicted positions of moon-induced gravitational waves, confirming that several tiny moons are actively sculpting the ring edges. Neptune's rings weren't fading or dissolving. They were alive, shaped by the invisible hands of nearby satellites. Even more remarkably, Webb's infrared sensitivity revealed the composition of the rings with new confidence. The glow indicated that the rings contained fine dust particles, larger icy grains, and likely organic compounds darkened by radiation. The way these materials reflected and absorbed infrared wavelengths gave scientists their clearest view yet into how Neptune's rings evolve and how quickly. But the most staggering implication was this: Neptune's rings are changing. Comparing Webb's data with Voyager's revealed thickness differences, brightness shifts, and dust density variations. This was a time lapse that had been waiting 33 years to be completed. For decades, the scientific community had believed Neptune's rings were too faint, too thin, and too unstable to study without a spacecraft flyby. Webb shattered that assumption instantly. The reappearance of Neptune's rings, clearer, brighter, and more detailed than at any point since 1989, was not just a victory for Webb. It was a revelation. Neptune hadn't been quiet for the last 3 decades. We simply hadn't been able to see what it was doing. And now, for the first time since Voyager, we finally could. The moon that outshines Neptune. When NASA first processed Webb's infrared images of Neptune, one object stole the spotlight. Literally, a single moon appeared so bright, so dominant, that several team members thought the telescope had malfunctioned. It wasn't Neptune, it was Triton. In Webb's infrared view, Triton outshined Neptune so intensely that researchers initially flagged the frames as potential detector saturation, a sign that the signal was too strong to be real. But after recalibrating the data, rerunning the exposure analysis, and checking the instrument logs, the conclusion became unavoidable. There was no error with the brightness. Triton was genuinely overpowering Neptune. The reason stunned scientists. Triton is coated in frozen nitrogen that reflects infrared light with extraordinary efficiency. Neptune, on the other hand, absorbs most infrared wavelengths because of its methane-rich atmosphere. In visible light, Neptune glows a striking blue, but in infrared, the planet goes dark and its moon explodes into brilliance. It created one of the most dramatic contrasts Webb had ever recorded in our solar system. A moon shining brighter than the planet it orbits. There was more to this than meets the eye. It was a scientific coup. Triton's infrared glare revealed fine details of its surface, texture variations in the nitrogen ice, changes in reflectivity across its southern regions, and subtle brightness shifts that matched decades-old predictions of seasonal migration of surface frost. These changes could hint at internal heat, geological activity, or even ongoing cryovolcanism, the nitrogen geysers. Voyager 2 blitzed in 1989. Webb didn't just capture Triton. It exposed the moon as a world with a story of its own, possibly still active, possibly still evolving. Even Neptune's smaller moons, often lost in the planet's glare, appeared clearly as bright, sharp points of light. Naiad, Thesa, Despina, Galatia, Larissa, and Proteus. For the first time in decades, scientists could track them all with precision, refining Neptune's gravitational model and improving estimates for how these moons interact with the rings. Triton's brightness also reinforced a long-standing suspicion. This is not an ordinary moon. It is a captured object, likely a former Kuiper Belt dwarf planet. Webb's data strengthens that view. The nitrogen ice, the retrograde orbit, the brightness signature, everything points to a body with origins far beyond Neptune. One that now dominates the system it was once trapped by. For NASA, this chapter of the Webb findings was an observation, but also a reminder that sometimes the biggest revelations aren't planets. They're the moons rewriting the story around them. The auroras. For decades, Neptune's auroras were little more than faint hints, buried in noisy data, unpredictable, inconsistent, and almost impossible to map. Every attempt to track them ran into the same problem. Neptune's bizarre magnetic field simply refused to behave. Its magnetic axis is tilted dramatically and offset far from the planet's center, creating a twisted, lopsided magnetosphere that defied expectations. Earlier telescopes grazed the edges of Neptune's auroral activity, but never produced a clear pattern. At best, scientists had guesses. At worst, they had contradictions. Then, Webb turned its infrared detectors toward Neptune, and everything changed. What Webb captured contradicted decades of models. The auroras weren't where they should have been. They appeared far from the predicted magnetic ovals, lighting up regions that every textbook said should remain dark. Instead of clustering around the poles, bright auroral zones appeared at unexpected latitudes, revealing a magnetic system far more chaotic than scientists ever imagined. Inside NASA, The reaction was immediate. Researchers rechecked the calibration. They verified timestamps. They confirmed the wavelengths. Everything came back clean. The auroras really were in the wrong places. Infrared imaging turned out to be the perfect tool for exposing the truth. Auroras emit heat and energy as charged particles crash into the atmosphere. Energy that stands out sharply in Webb's filters. These glowing patches were unmistakable. They weren't clouds. They weren't reflections. They were auroras operating outside every established model. This discovery made one thing undeniable. Neptune's magnetic field is far more dynamic, unstable, and unpredictable than scientists previously believed. The offset geometry may be channeling solar wind energy into regions no one expected. Changes in solar pressure, internal currents, or Triton's own ionosphere may be dragging auroral activity across the planet like a shifting spotlight. For researchers studying ice giants, the very planet class that dominates exoplanet discoveries, this was a seismic moment. If Neptune's magnetosphere behaves this unpredictably, then similar worlds, orbiting other stars, likely behave the same way. Webb didn't just locate auroras. It exposed a magnetic system that forces scientists to rewrite how ice giants process energy, interact with solar winds, and evolve over time. This discovery wasn't quiet or predictable. It proved that even in our own solar system, some planets still refuse to follow the rules we expect them to. The implication. When NASA scientists finished analyzing Webb's Neptune data, a realization settled over the room. Slow at first, then unmistakable. This wasn't just a clearer picture. It was a correction, a course change, a rewrite of the planet we thought we understood. Ice giants like Neptune and Uranus dominate exoplanet discoveries. They are everywhere, orbiting red dwarfs, sun-like stars, and even rogue between system spaces. Yet until Webb, the best blueprint scientists had for this entire class of planets was a handful of incomplete snapshots and theoretical models. Webb shattered that foundation in weeks. Infrared clarity revealed rings with structure no one predicted, cloud systems layered like clockwork, temperature patterns that contradicted long-rusted models, and auroras behaving as though Neptune's magnetic field were twisting itself in real time. What scientists had treated as baseline assumptions suddenly looked fragile. The implications ripple far beyond Neptune. Neptune is now the reference point for entire worlds across the galaxy. Everything learned here, methane behavior, heat transport, ring evolution, magnetic instability, cloud chemistry, becomes the template for studying distant ice giants that cannot be imaged directly. Astrophysicists studying exoplanets are already rewriting the rulebook, the way methane scatters light, the way heat escapes from deep interiors, the way tilted magnetic fields warp weather systems, the way ring material persists longer than expected. These are not local quirks of one planet. They are characteristics of a planetary type. Before Webb, exoplanet researchers had to guess how many of these processes worked. Now, they have a living example captured at a resolution Voyager scientists could only dream about. Then came the most surprising implication of all. Neptune emits more internal heat than models predicted. Far more. That extra energy shades everything from cloud formation to ring brightness. And it suggests that Neptune's interior is not quiet or static. It is active, changing, possibly layered in ways that challenge previous ideas about what lies beneath the surface of an ice giant. Webb didn't just sharpen Neptune. It exposed a world that refuses to behave and a category of planets that may be far more extreme, dynamic, and unpredictable than scientists believed. For NASA, that shock was a turning point, a reminder that even familiar objects in our solar system can overturn decades of certainty. The moment we learn how to see them clearly, the unexpected patterns. When scientists finally overlaid all of Webb's Neptune data, the rings, the atmosphere, The moons, the auroras, something unexpected surfaced. The features didn't behave like independent mysteries anymore. They aligned. They synchronized. They formed a pattern no telescope had ever exposed before, and certainly not in a single observing session. It began with the rings. Their infrared brightness rose and fell in precise rhythmic intervals. These weren't random streaks of dust. They were gravitational fingerprints, repeating in ways that matched the tiny orbital irregularities of Neptune's inner moons. Voyager 2 had hinted at this behavior, but only faintly. Webb revealed it with mathematical clarity. Then, researchers noticed the atmosphere. Neptune's infrared brightness wasn't symmetrical. One hemisphere glowed slightly warmer than the other. When they traced the source, it led straight to the locations where Webb detected auroras. Except those auroras weren't where any model predicted they should be. The magnetic field was funneling energy into the wrong latitudes, warming regions that were never supposed to receive that much interaction from the solar wind. It was the first direct evidence that Neptune's magnetic system was influencing its weather in real time. The next anomaly came from Triton. Webb didn't just show Triton as bright. It showed subtle variations in brightness across its frozen surface. Tiny changes in nitrogen ice reflectivity that matched long-term predictions about seasonal ice migration. That meant Triton was responding to temperature changes across Neptune's orbit, possibly even to internal heat. For the first time, scientists could watch those shifts instead of inferring them. But the biggest pattern appeared only when cloud height, temperature, and infrared brightness were digitally stacked together. Suddenly, the noise sharpened into structure. The clouds weren't floating randomly. They traced deep atmospheric pathways, rising columns of warm air, sinking regions of cold gas, and circulation loops that wrapped around half the planet. Neptune's atmosphere wasn't chaotic. It was organized, structured, and driven by forces that models had never correctly mapped. And that's what left NASA stunned. These weren't isolated discoveries. They were signals from a single interconnected system. Rings shaped by moons, auroras altering the atmosphere, a captured moon undergoing seasonal changes, and cloud patterns mapping internal heat flow. None of these relationships had ever been confirmed in the same dataset. None had ever been observed with this level of precision. For the first time in 30 years, Neptune stopped being a distant blur of storms and shadows. Webb revealed the planet's underlying architecture, a hidden logic shaping everything from its ring brightness to its magnetic energy to the way clouds form and disappear. This wasn't just a clearer picture. This was Neptune rewriting itself in real time, rewriting what we knew. When NASA finished its first full analysis of Webb's Neptune images, the conclusion was unavoidable. The models weren't just incomplete. They were wrong in several key places. And the shock came not from one dramatic discovery, but from how many parts of the planet suddenly made sense once the new data was compared side by side with 30-year-old Voyager images. The rings were the first blow to old assumptions. For decades, scientists believed Neptune's rings were fading, dispersing into space at a slow and predictable rate. Webb shattered that idea instantly. The structures in the rings were sharper than expected, not weaker. Their arcs were stable. Their dust bands were still intact. Even faint variations showed gravitational shaping that older models said should no longer exist. Instead of a dying ring system, Webb revealed one that was very much alive and far more complex than Voyager ever hinted. Then came the auroras, appearing in places no one had predicted. Neptune's magnetic field had long been modeled as erratic and offset, but even the most flexible simulations failed to predict auroras glowing far outside the expected zones. Webb forced scientists to confront the reality that Neptune's magnetosphere behaves in a way no other planets does. bending, warping, and channeling energy in patterns that contradict decades of predictions. Triton delivered the next surprise. Its intense infrared brightness wasn't just visually striking, it carried meaning. Variations in its nitrogen ice aligned with long-hypothesized seasonal shifts. And some researchers argued that the brightness changes might even suggest internal activity. Webb didn't just show a brighter moon, it showed a changing moon, one that might be more geologically active than assumed. Meanwhile, Neptune's atmosphere revealed a pattern that contradicted the standard model of heat flow on ice giants. Webb's data made clear that heat is not distributed evenly around Neptune. Instead, deep internal circulation cells are moving energy upward in narrow channels, something unseen but long suspected. Webb didn't just confirm it, it mapped it. Every one of these findings forced a correction. Not a small adjustment, but a fundamental shift. For the first time since Voyager 2's flyby, scientists could see Neptune as a fully connected system, not a set of disconnected mysteries. Webb provided a level of detail no one expected from a telescope built to study ancient galaxies, and NASA's own researchers admitted privately that the new data rewrote sections of their internal reference models almost overnight. 3 decades of theories now had to be reevaluated. Neptune wasn't the quiet, distant ice giant they thought it was. It was dynamic, active, structured, and far stranger than the old assumptions ever allowed. Webb didn't just give Neptune a clearer face. It forced science to update the story entirely. If a distant ice giant can reveal this much once we look at it in the right way, what other planets nearby or across the galaxy might be hiding equally unexpected behavior beneath familiar appearances? Share your thoughts in the comments. Thank you for watching this video with us, and catch you in the next.